In this video, I'm going to show a quick demonstration on file filtering. So, say you have a hard drive to analyze and it's got tons of files on it. Say it has an operating system or just a whole set of many files. So for a forensics investigator, this quickly could become like a needle in the haystack problem where they're looking for one file or they're looking for small signs of malicious activity, yet they have a collection of thousands of files and they may have to analyze all of them to find the one file they're looking for. So a technique we can use to reduce the complexity of this problem is where we can filter out files, either known good files, so say system files from say an installation of Windows XP, or we could filter out known bad files, such as files commonly associated with malicious activity like keyloggers, by comparing the hashes of the files on our drive to previously created hashes of commonly known files. So, say for example, we have an installation of Windows XP. So many of the system files in Windows XP obviously are exactly the same over all installations and don't change once you install them. So if we can compute the hash of these files, we can then compare this hash. We can compare the hashes from this hash set of all the system files on Windows XP to the hashes on our drive and determine if any of them match. And if any of them match, we can know that those files we can now safely ignore. So what we're going to do now is I'm going to demonstrate how this works using OS Forensics. I'm going to assume you already know how to use OS Forensics. I'm not going to show how to use it. I'm also going to assume that you've been able to import the hash sets that we're going to use. The hash sets are just a collection of hashes for, say, Windows XP. I have some here. I have the Windows XP Professional 32-bit hash set, etc. You can see some other ones here, one for keyloggers, etc. So I'm going to assume that you've already seen how to import that. I discussed that in the presentation slides and the resources section, how to get those. And these are hash sets that are formatted to work with OS Forensics. They basically either are pre-installed or can be obtained from OS Forensics. Other hash sets like the NSRL, which cannot be imported in the free edition of OS Forensics, are more extensive, but we don't use them here for simplicity and because they won't work well with OS Forensics. But what we're going to do is I've gone ahead and taken 4 files from my computer, 4 system files, and I've copied them to a new directory. And what we're going to do is basically compute the hash of those files and then check them against these hash sets to see if they match. And if we find those files in there, obviously those files are obviously they're good. Whereas if we don't, we would still need to investigate them to make sure that they're not suspicious. Just so you know, I've gone ahead and combined all the safe hash sets here, so the Office ones and the OS ones here, not the keylogger one, into one giant hash set. And you can see them all down here. And we're going to use this hash set, or this set of hash sets, really a database, for our analysis. I've done that by clicking Make Active, and now we're using this hash set. So to check hashes, what we do is we go to the file name search section. I've already provided, you'll give it a start folder where you want it to look, where your hashes are. So that can be an image of a drive that you have, or it can be a folder. In my case, it's a folder on my desktop where I've copied my files to. I'll then hit search, and I'll find that there are 4 files that I've put here, 4 files to search. Now, I could do one of 2 things. I could either, whoops, open that. I can either search for this file in the hash set individually by clicking look up in hash set, and you can see it searching for it, and it's taking its time, but you can see that it was found in 6 of the hash sets we gave it. Remember, it was a hash database of a lot of them, and it tells us it's hashed and that it's a good file, and what the file name is in the hash set, etc., showing that clearly this is a system file that we don't need to worry about. And I'll get some more information over at it here too. The other thing I could do is select all the files here and then look them all up in the hash set, and it'll show that we hashed 4 files, 3 of them were found in the hash set, and when we close that we will see that this file, and this file were in the hash set, leaving us with just this file which wasn't, which we would then have to sort of analyze. So clearly this is a quicker way to reduce the the number of a quick way to reduce the number of files we need to analyze, so that we don't waste a lot of our time looking at, in this case, 75% of the files were good, so we don't waste our time looking at 3 files that we didn't need to analyze. Obviously, this becomes a little more complicated when there's more files, because you'll get a lot more, you'll get a lot less matches. You'll have more files you need to analyze. But it's good from both perspectives. Of either you can use it to remove known good files for like operating systems, or you can use it to single out bad files, such as if we were to use the hash set called keyloggers. We were to run that against a set of files, and we would find out which files are commonly associated with keyloggers, and that would help us detect malicious activity. So hopefully this was helpful. I wanted you to sort of understand the whole topic of file filtering, how you can hash your files and compare them to previously computed hash sets. Obviously you can do that with OS Forensics, but that wasn't just the purpose of this tutorial to show you how to do it with OS Forensics. It was more to show you that this topic exists and how you can use it. So I hope this was beneficial, and that's it.